We're still in Math 098, Section 2 of Chapter 3. So I'm labeling this 3.2b for anybody following. So as I do this problem, as I mentioned earlier, you look at the inequality as if it's an equal sign. And if I were doing this problem, I would distribute that negative in. You don't have to do it my way, but this way does work. Distribute that 2. So we're looking at 10x plus 18. Leave that 2x alone for a second. Now combine like terms. So we're looking at 12x on the right side. By the way, if you're good at math, you might be able to do multiple steps at once. So then subtract 12x to the left side. Yeah, let me go ahead and do that. I'm going to add 6 to the right side. So what I'm looking at, I'll switch colors and move to this side. Negative 4 minus 12 is negative 16x. Is still less than or equal to, because the sign stays the same. 18 plus 6 is 24. And as you divide by a negative, you are going to flip this inequality to say that x is greater than or equal to, we'll divide both those by 8. Whoa. Yeah. Is negative 3/2. Yeah, we're right here. Now, notice that I wrote x is greater than or equal to, and this is the first time that I haven't told you to check your work yet, but you can check your work by the use of Desmos or your graphing calculator. How? Well, let me show you. By the way, if you need to pause, go ahead and pause, because in a few seconds Desmos is going to be on the screen. So I tried to save you some time, and I went ahead and just graphed the two equations exactly how they look. Notice that the top equation is red, and if I go back to the problem, remember I wanted where this, the red equation is less than. Well, what does that mean graphically? If something is less than, it means it needs to be below the other function. So as I look at Desmos, I'm looking at where the red curve is below the blue curve, and that happens to the right of negative 1.5. Well, if you're unaware, negative 1.5 as a fraction, click that OK, is negative 3/2. I don't know if you know that trick with Desmos, is if there's a fraction, they will change it for you. Well, and that's exactly what we said. So that's how you can check your work graphically with the use of Desmos to see where the graph is below. Well, what if this was the opposite and it was flipped? Well, you would be looking at where the graph is above the other. Maybe I should explain what this greater than means. Well, if x is greater than, it needs to be to the right of that value. So that's exactly what I was saying, is we're to the right of this. I've never done this before. I wonder if I write x is greater than or equal to negative 3/2. Okay, so it shades it for you. I guess you can see exactly what we mean by that. Values to the right. And you can see the blue curve, you can barely see it now, is above the red curve, only to the right of that value. I don't know if that's helpful or not, though. So let's keep working through. Let me move this back. That's going to bother me if it's not centered. And work through the next one. So as you distribute 3/5 in here, at least this is how I would do the problem. 3 times 3 is 9, stays fifths. It's greater than or equal to x minus 7. Well, I would subtract x to the left side, and if you get the same denominator as 1, you can change it to be 5/5 is equal to 1. And same thing with this 7, you could change that 7 to be 35/5. Now it is negative 35/5. Maybe I'll just show that for you. So when you add 9/5 to the right side, because these fractions aren't that bad. Trust me when I say that. 3 minus 5 is negative 2. The denominator stays the same. So adding this over, negative 35 plus 9 is negative 26. And so what you can do now is you can solve this. Now don't forget, when you multiply or divide by a negative, you have to flip that inequality. So the reciprocal of this is negative 5 halves. So you have to multiply this by negative 5 halves. And you can see the negatives will cancel, the 5s will cancel, the 2s will cancel. That's why I'm a big fan of this. Don't forget to flip that inequality. Well, this is easy because the 5s cancel, the negatives cancel, and 26 divided by 2 is 13. I told you it wasn't that bad. If you have another way of doing this, feel free to do the problem that way. I think I forgot to answer the earlier one in interval notation. It doesn't tell you to. So interval notation, because it's infinitely to the left, you would say negative infinity until you get to 13 with a bracket. All right. Now let's check with Desmos. So I can pull up Desmos and cross all this stuff out. It was 3/5 times x, I already forgot what it was, minus 3. And then the other equation, y equals x minus 7. And how it's written is we want the first equation I drew in red to be larger than the other equation, which is in black. So you can see on my curve that the red equation is larger than the black equation until we get to this, and then they switch. Well, if you were to write an inequality that said x is less than or equal to 13, you can see, I wish it was a different color, but that encompasses everything from negative infinity until you get to 13, and then you stop. So that's how you can check graphically how to get there. So the next one is just asking you to solve algebraically. Well, if you notice with this problem, you end up with 2x plus 6 as you distribute is greater than 2x plus 1. And I'm just going to do one more step because I think we can answer this. These will both cancel, and you're just left with 6 is greater than 1. Well, what does this actually mean? Well, we're back to the previous section where this means x could be anything. But in interval notation, we're going to write negative infinity to infinity. There's x can be anything. Well, what does that actually mean? Well, if we were to graph these two functions, 2x plus 6 and 2x plus 1, we're going to get a line like this and a line like this. Well, 2x plus 6 is always going to be bigger than 2x plus 1. This will always be true. So be careful with this, because in the previous section when they were parallel lines we said it was no solution. Well, in this case we found parallel lines where everything works, and it's all because of the inequality. Now sometimes when I explain this to students, I just ask them, is this a true statement? Is it, when the x is canceled, are you left with a true statement? Well, 6 is always bigger than 1. That is true. So that is infinitely many solutions, all real numbers. So how can we change this ever so slightly? Well, if you notice, it's the same exact problem, except I switched that inequality. So there's still parallel lines, but now we're left with a false statement. 6 is never smaller than 1. And therefore, you can either write no solution like that, or you can actually write out no solution. You'll probably see me write it as no solution, but I'll let you write it the other way. And it's the same graph. But the problem is that the top function is never smaller than that one. That's why it's no solution. So a little tricky, but you guys are all good. You're capable of doing this. Exercise 8 is another one where they tell you this person makes $900 no matter what, plus 15% commission, so 0.15x, depending on how much the salesperson sells. Find the minimum amount of sales. Well, if I read minimum, I'm thinking at least, so that needs to be greater than or equal to the 2,400. So setting up the problem is probably the most difficult part, but once you do that, it's pretty straightforward. Subtract 900 over. So 0.15x must be greater than or equal to 1,500. And I can't do this in my head. I'm going to go to a calculator. Divide by 0.15. So x must be $10,000 in sales. Greater than or equal to. And there's just one more problem. Again, it's a word problem, but then you'll be ready to do your homework. By the way, reminder to pause the video if you get stuck anywhere. Again, pause the video, make sure you understand the question. So you're given this equation. Make sure you understand that this is the years after 2000. Use this formula to predict the years that will be less than 200 billion. So if you were to, here's another piece I guess I should say, that C is in billions. So let's just say if it was the year 2000, hypothetically, that means t equals 0, and you plug that into the problem. Well, anything times 0 is 0 plus 431. So it's telling us that we're starting at 431 billion. So I know this is just an equal, like all they do is they give you an equal sign in the problem, but all you have to do is plug in 200 for C, and C, I wrote down T too soon, 9.4 T, and solve for T and just say that T needs to be bigger than that number. And I hesitate to put in inequality here because students tend to confuse what inequality is this, and then when they divide by a negative they remind themselves that they have to switch the inequality. So I think it makes perfect sense that if we're starting at 431, the only way to get it less than 200 would be after solving for it. And it makes sense in my head. I hope you're okay with that. So subtract 431 over. That's negative 231 is equal to negative 9.4. And then to solve that, you divide. So T is going to be greater than, I'm just going to do greater than because the time needs to be past 2000. Where's my calculator? Negative 231 divided by negative 9.4. I think it was 9.4. Yeah. So about 24.6 years, or 24.574 years. But if you were to tell me the year 2024 or 2025, because you want the year after, I would accept that for full credit as well, depending on how the question is asked, and go from there. So here's your assignment, and you should be good to go. And thanks for watching.